Alright, number 3, we want to find all the factors of 100. So I'm going to use that same method I used in the previous problem. I think the book just says try to divide it by 1, 2, 3, so forth and so on. That might take some time, and you could miss, because who knows how many numbers you'd have to use. So it's best to just go straight forward. So we're going to do 100. We're going to break this down to primes. I'm going to break this down to 2 times 50. And what I like to do once I break it down, I'm going to scratch it out. I didn't do that before, but I'm going to show you. Every time I draw a line from it, I know that's not one of my prime numbers. 50 we can break down to 2 times 25. And then 25 we can break down to 5 times 5. Okay, so here are all my prime numbers. 2 times 2 times 5 times 5. Now, I'm not going to write it in exponential form. Because I want you to be able to see what numbers I'm using and how I'm coming up with all of these factors. Okay. So, first I'm going to start out with 1 and 100. Okay. Now, the next largest number after making 1 I can make from these factors is just the number 2. So if I use one of those 2's, then what I have left is 2 times 5, which is 10, and 10 times 5 is 50. So basically those two numbers. So I'm going to come over here and write 50. Alright, so I cannot make a 3 from these, but I can make a 4 with 2 times 2. Alright, so if I did 2 times 2, that would give me 4. So that means 4 is a factor. And then once I use 4, 5 times 5 is 25, so that will be the other number. So 4 times 25 also gives us 100. Now the next number I can make, I can use a 5, just one single 5. So 5, if I use a 5, the numbers I have, 2 times 2 is 4, and 4 times 5 is 20. So whatever you don't use, you multiply all those together and make your other number. All right? We can't make a 6 or a 7 or 8 or 9, but we can make a 10. 2 times 5 is 10, and then we still have 10 of the other number. So just 10 in the middle, which is good because I'm just out of room. So these are all the factors of 100. So just use all possible combinations of your prime factor. We're going to say 1, 2, 4, 5, 10, 20, 25, 50, and 100. Alright, and then we're going to use the divisibility rules to determine whether 9,128 are divisible by the following numbers. Okay. So is this divisible by 2? We know what it ends with. So it ends in a 0, 2, 4, 6, or 8 if it ends in an even number. So yes, it would be. Alright, is it divisible by 3? Alright, so let's actually go over. So we're just going to go 2, 3, 4, 5, 6, 8, 9, 10, and 12. Okay, so let's just write this down. 4, 9, 1, 2, 8. And I'm going to say 2, check, 3. We have to add up the digits. So I'm going to say 9 plus 1 plus 2 plus 8. That's 10, that's 20. 20 is not divisible by 3, so not 3. 4, we look at the last two digits. 28 is divisible by 4. So yes, it's divisible by 4. Divisible by 5, nope, has an end in 5 or 0. Divisible by 6, only if it's divisible by 2 and 3, and it's not divisible by 3. So no go on 6. We don't have a rule for 7. For 8, we have to look at the last 3 digits, so I'm going to have to actually divide 128. Let's see if 8 will divide that. 8 will go into 12 once. Bring down to 4, you subtract, bring down to 8, and 8 times 6 is 48. So yes, it's divisible by 8, divisible by 9 if the sum of the digits is divisible by 9, and 20 is not divisible by 9. Divisible by 10 if it ends in a 0, so no. And divisible by 12 if it was divisible by 3 and 4. That was a rule. So not divisible by 3, so no. So that will do all of these for us. So divisible by 3, we say no, enter. Some space so I can see yes and no. Just gonna scroll down a little bit. Alright, divisible by 4, yes. Divisible by 5, no. I'll have to put in the right answer at the top for me. Divisible by 6, no. Divisible by 8, yes. Divisible by 9, no. Divisible by 10, no. And divisible by 12, no. So those are the rules. If you have them out to the side, you can kind of go through it pretty quickly.